So here's a basic explanation of the robot I've been working on. So it's a mechanism drivetrain, it has mechanism wheels. How it works is that there are two motors stacked on top of each other, and how the motors are connected to the mechanism wheels is there's a pulley, there's a belt and a pulley that kind of rotates here. There's a differential in the center that makes it so that it translates from one direction rotation to another direction rotation. And here's some bearings that allow it so that it doesn't like interfere with the rest of the chassis. So yeah, it's connected by a belt and pulley, and they're stacked on top of each other, which allows for a lot of space in the middle for other things. On the sides, there are linear slides powered by motors. In the center here is our main outtake. How it works is, first there's a motor in the center here, a high torque motor in the center here that powers a differential that rotates the main part of the outtake. It like spins it on this axis of rotation, basically. And these two servos here are connected by a belt and a pulley to control the claw here, which allows it so that regardless of what direction, like regardless of how many degrees this main part has been rotated, this can always be whatever we want it to be. The claw's angle can be whatever we want it to be, which is pretty useful for when grabbing samples on the player side. Not sample specimens, yeah. So this is the intake. How it works is that there are two rollers here, well, 6 rollers, but two main rollers powered by 2 servos, one here, and there's a differential in the back. So how it works is I'm assuming that these roller wheels will be pretty flexible, so it can just like, we can just like basically slam down onto not slam, but pretty fast motion down onto the sample, and it'll just like automatically pick up. It'll fly through these doors and kind of be like funneled into this kind of shape that we want it to. Wait, let me hide the sample. So there's a hinge here, connected to a door here. What that allows it is that it can go upwards through the doors and then come back down and not fall back through. And this allows it so that there's easier claw, so that the claw has easier access to the sample when it comes through. And it's powered by so the way that the intake works is it's a coaxial 4-bar virtual 4-bar, which means that it stays parallel to so this entire contraption here stays parallel to the ground because of how the pulley and everything else is set up. Like the pulley here is directly connected to the intake instead of through a bearing or something else that allows it to freely rotate. And there's again pulley and belt connecting these two here. This one is directly connected to a servo here, which allows for rotation up and down, and it allows the claw to actually grab onto it. So in the beginning, when we actually start, the way that the robot is going to be is that this will be moved a lot backwards, so that it's not going to be outside of the 18-inch by 18-inch sizing constraints, and this will be moved slightly upwards. This is just the way the model is right now. So inside in quotations, but inside we have a core hex motor, core hex motor that powers the linear slide on the side instead of like a motor that directly connects to a belt and pulley here. So how this works is that there's scissoring on the sides, like there's scissoring on the sides that connects to the slide here, and it doesn't connect to the back here. So how it works is that when this this rotates not counterclockwise. When this rotates clockwise, it'll expand outwards, and when it rotates counterclockwise, it'll come back. And that's directly connected to the servos here, connected to the intake here. There are odometry pods on the bottom. That's pretty self-explanatory. And here's the power switch, and this is basically it. So here's how it looks like on the field. It's tall enough. So the way that it is right now, it's good enough to actually like put it onto the high rung here. Like when we get samples or when we get specimens on the claw, it'll be good enough to actually put it onto the second bar here. And we can do a basic level 1 quote unquote ascent, where it's just touching the top rung here. And the linear slide moves up and down so that it can score into the baskets here. So here's some other schematics of the robot. I'll just fly through these pretty quickly. This is the upper outtake. Still the upper outtake. This is the intake. This is the expansion. This is how the scissoring is wired. Not the scissoring is wired, this is how the scissoring is connected. This is a front view. Other dimensions. And we're circled back through. All right, that's it.